So specifically with, I know some people are from out of state, continuous simulation is required in Western Washington for doing stormwater design. You can't use single events, you can't use hydrographs, you can't use SES, rational, or any of that. You have to use a model called HSPF, which runs continuously every time step, every drop of water, everywhere in your watershed, using real rainfall, real evaporation. And so that model, HSPF, is really complicated to use, and so we wrote a program called the WWHM that incorporates HSPF, but in a user-friendly way that actual people can use without spending years trying to study the software. This is just an example of a couple of years of data from the model. The LID in the model, what's really important about the LIDs is most of what they do performance-wise in terms of infiltrating or evapotranspirating water takes place in between the peaks, in between the large events. It's this stuff that you have to track to see what's really going on with something like a bioretention unit or other forms of LID. So that's what we're talking about with this. Go ahead. People know it by a lot of different names. Basically, they all perform essentially the same, depending on how you set them up. But there's rain gardens, bioretention swales. Different jurisdictions name them different things and require different design features for each one of them. So we're going to be, focusing, calling everything that we talk about it bioretention. So it's a typical looking bioretention unit after it's been constructed. You have surface with the plants where you're trying to evapotranspirate things. You have the medium that's engineered that has a certain performance threshold. In Western Washington, DOE has specifications on what that medium has to be in order to be used. Oftentimes you'll have a gravel area beneath it where you can put in an underdrain. You can put in an underdrain to drain the water out of it after it's filtered through the soil, or it can infiltrate into the existing native soils below. The evaporation is tracked from both the surface and the subsurface.
And so, this is just kind of reiterating what the bioretention does. This is kind of a detailed schematic of it. So it can provide water quality and hydro modification, meaning flow frequency or storage requirements. So it can do both, but mostly used for filtering the soil mediums and preventing pollutants from entering the streams. And bioretention is a very effective LID solution and can be used in a variety of ways, sometimes in sequence, sometimes large, sometimes small, and even sometimes broken up in different locations. It just depends. And so Washington State specifies in the Western Washington hydrology model has to be used to model this bioretention facility. And so you can see it kind of has a downslope here as the water is able to filter through the different soil mediums and then go out through an underdrain or eventually infiltrate into the native soil.